So this is GPT-5.3 Codex-Spark and it writes code at over 1000 tokens per second. That's 15 times faster than what you are used to. But here's the thing, speed is only half the story, because what OpenAI just announced is not just a faster AI, it's the first AI that was used to build itself. Okay, so here's what just happened. Last week, OpenAI dropped not one but two models, and the timing was intense. Hours after their biggest competitor Anthropic released Cloud Opus 4.6, OpenAI fired back with GPT-5.3 Codex. And understanding what these models actually do makes this announcement so significant. Usually, most AI models are good at one thing. GPT 5.2 was amazing at reasoning, like PhD level thinking. GPT 5.2 Codex was incredible at writing code, but they were a separate model. You had to choose. GPT 5.3 Codex is both combined in one model. It's more than 25% faster per token. It can work on task for hours without losing track. And here's the crazy part, it helped build itself. The Codex team used early versions to debug its own training, manage deployment, and diagnose problems. An AI debugging the AI that makes the AI. But then they did something even wilder, because understanding Codex-Spark requires talking about a fundamental problem in AI: latency. When you use ChatGPT, there is a delay. You type something, hit enter, and wait. That wait comes from three things. First, the time to process your input, we call that prefill. Second, the time to generate each word, that's called sampling speed. And third, all the network overhead, the digital equivalent of your message traveling across the internet and back. Most AI runs on GPUs, graphics card. They're incredibly powerful, but they weren't designed specifically for this. They are general purpose tools that we've adapted for AI. Then enter Cerebras. This is the Wafer Scale Engine 3. It's not a chip in the traditional sense, it's an entire wafer, 46,255 square millimeters. And to put that in perspective, one of the biggest GPU from NVIDIA is about 800 square millimeters. This is 56 times larger. Inside is a 4 trillion transistors, 900,000 AI cores, 125 petaflops of performance. But size is not the magic here. The magic is specialization. This chip was built from the ground up for one thing: ultra low latency AI inference. And that changes everything. The difference in practice is remarkable. Regular GPT 5.3 Codex is impressive. It can build entire games, racing games with 8 maps, different racers, power-ups, or diving games where you manage oxygen, pressure, hazards, and it does this over millions of tokens, iterating autonomously for hours. But Codex-Spark on Cerebras hardware feels different. Instead of that slight pause before the response starts, it's instant. Like talking to a person, you can interrupt it mid-sentence and steer it in a new direction. You don't lose context. It feels collaborative instead of transactional. The infrastructure improvements are specific. OpenAI reduced time to first token by 50% through Spark's optimization. The per token generation is where that 15 times speed advantage really shows up. Spark is currently in research preview. It's optimized for real-time collaboration and rapid iteration. Meanwhile, the full GPT 5.3 Codex handled those complex hours-long autonomous tasks that require deep reasoning and extended context. Think of it like having both a sports car and a truck, different tools for different jobs. And if you're finding this breakdown helpful, why don't you like, subscribe, and comment? Now, here's where things get complicated. GPT 5.3 Codex is so capable at code that OpenAI classified it as high capability for cybersecurity. That's their internal risk system, and this is the first model they've ever put in that category. The same AI that can build you a beautiful website or debug your Python script could also find vulnerabilities, write exploit, potentially automate attacks. OpenAI doesn't have definitive evidence it can fully automate cyber attacks, but they can't rule it out. So they are being careful, really careful. They've deployed what they call their most comprehensive cybersecurity safety stack to date: safety training, automated monitoring, something called trusted assets for cyber, where advanced features are gated to verified researchers only. They're even launching a 10 million program to give free API credit to open source maintainers for security scanning. In their evaluations, the model scored 80% on the Cyber Range benchmark, a test where the AI has to identify and exploit vulnerabilities. That's That's impressive and concerning in equal measure. This is the paradox of powerful AI. The more capable it becomes, the more carefully we have to deploy it. And this brings us back to Cerebras, because this is not just about one model. OpenAI and Cerebras announced a multi-year partnership worth over $10 billion. They are deploying 750 megawatts of wafer scale system. That's enough power to run a small city, but it's not replacing GPUs. That's important to note. GPUs are still foundational. They are cost-effective, flexible, proven at scale. Cerebras is complementary. It's for the workloads where latency matters most, where that instant feedback loop changes how you work. And Spark is just the beginning. OpenAI says they are working on larger models, longer context windows, multimodal inputs, all optimized for this ultra-fast experience. And the benchmark scores back this up. State-of-the-art on SWE-Bench Pro, which tests real-world software engineering across multiple programming languages, far exceeds previous results on Terminal-Bench 2.0. And it achieves all of this with better token efficiency than any prior model. So that's GPT-5.3 Codex and Codex-Spark, an AI that helped build itself, running on a chip the size of a dinner plate, fast enough to feel like a conversation, powerful enough that we have to be really careful about how we release it. The future of coding isn't just about writing better code, it's about working with AI in real time, and that future just arrived.